Hello folks, we are once again back with this exercise 7.5. Now it is the problem number 18. Now the problem number 18 is very different from the other problems in the sense that we can see that there is a x squared plus 1 in the numerator times x squared plus 2 in the denominator, x squared plus 3 times x squared plus 4. The highlight point over here is the numerator and denominator, they both have the same degree actually. 4 degree 4 in both in the numerator and denominator, but then so therefore we know that we have to do division, but here it doesn't work so easily because it's x squared both in the numerator and denominator. So there is going to be a lot of substitution that we are going to do out of the integral, and after making it pretty simple, it's only later that we will go in for the integral. So it's a very different kind of problem. We have to pay attention to each step, and by no chance we should step inside the integral. If you step inside the integral, then you're not able to do the work. You're going to take that entire integrand outside, work a lot with it, and then get inside the integral. That's how our work is going to be. So let's see how to go about it. Let's consider x squared plus 1 times x squared plus 2 over x squared plus 3 times x squared plus 4. To this fraction, you just consider y as x squared. So this particular thing can become equal to, so therefore x squared plus 1 times x squared plus 2 over x squared plus 3 times x squared plus 4 is now reduced to y plus 1 times y plus 2 y plus 3 times y plus 4. These factors are of no use to us, so let's make it a quadratic and then right away go for the division. So the quadratic on the numerator is y squared plus 2y plus y plus 2. Please note that. So it will become y squared plus 3y plus 2. We can do the expansion. Y squared plus 2y plus y plus 2. And denominator is y squared plus 3y plus 4y plus 12. So that way 7y plus 12. Both same degree, as we always tell, same degree, we are going to go for division. So let's divide y squared plus 3y plus 2 with y squared plus 7y plus 12. It's very clear that degree 1 will be only multiplied by y. So y squared plus 7y plus 12, we are going to change sign because it's a subtraction. This is going to cut each other. 3y minus 7y minus 4y minus 10. 2 minus 12 is minus 10. So when we write therefore the y squared plus 3y plus 2 over y squared plus 7y plus 12. We know that dividend equal to divisor into quotient plus remainder. So your divisor is y squared plus 7y plus 12, quotient is 1, plus remainder is minus, if you want to take out 4y plus 10 over the whole thing. Now denominator is applicable to both the terms. So first term is just 1 and second term is minus 4y plus 10 over y squared plus 7y plus 12. Now if we happen to take it in the integral, then this is going to be easy. Integral dx is fine, but this is going to be a trouble because it is not simplified. You have a quadratic in the denominator and a linear in the numerator. So we have to bring in partial fraction, simplify it and then go for the integral. So let's consider this part alone. Consider 4y plus 10 over, let's look at it as a factor because we are going to apply partial fraction, so that will be more applicable to us. 2 linears in the denominator, we all know that we will write it as a over y plus 3 plus b over y plus 4. Now that's by partial fraction. Now let's equalize the denominators. This whole fraction multiplied by y plus 4, this whole fraction multiplied by y plus 3. So it's a times y plus 4, b times y plus 3 over y plus 3 times y plus 4. On the other side, 4y plus 10 over y plus 3 times y plus 4. So denominators can cancel each other and we are left with a times y plus 4 plus b times y plus 3 to be equal to 4y plus 10. In order to get the values of a and b, let's make substitutions. If y is negative 4, a vanishes and b becomes b times negative 1 minus 16 plus 10 minus 6, b becomes 6. So also if y is negative 3, b vanishes, so a times 1 equal to minus 2, so a is negative 2. So like that you have both the values now. Actually with this I think we can enter into the integral sign I is, start from here, integral of 1 minus, this you have changed to this, so it is a, which is negative is there, so plus 2 over y is x squared plus 3. Again there is a negative sign outside, so it will be negative 6 over y plus 4, that is x squared plus 4. This is our final integral. So it's going to be integral dx plus 2 integral of dx over x squared plus 3 minus 6 integral of dx over x squared plus 4. That's quite simple now. Integral of dx is x for us, and then this is x squared, 1 over x squared plus a squared is 1 over a tan inverse of x over a. A is root 3 the whole square. I mean a squared is 3, so a is root 3. So 1 over a, so sine inverse of, sorry not sine, tan inverse of x over a. So also negative 6 over a, so it's going to be 2 here, tan inverse of x over 2 plus c. So if you want modified simplified version, 2 over root 3 tan inverse x over root 3 minus 3 tan inverse x over 2 plus c. Yeah, we'll just quickly check if everything is going on fine. That's it. So this is the answer for this. So we have to be careful, as I told you, that many things we are doing out of the integral, and once we have applied partial fraction, we go back to the integration and then try to do the integration. That's how we get across doing this problem. Couple of times this problem is coming again in the chapter. So always remember that when you have this kind of problem, this is a substitution that you have to do, and this is how you have to be outside the integral and then come inside the integral after applying partial fractions. So that's all for this video. With the next problem, let's meet in the next video. Thank you for that.